So the last presentation for the day, Sudarshan Sridhara from Capgemini, presenting to you performance predictive analytics using AI and machine learning. This is a pre-recorded video.
Good evening, innovators and thought leaders across the world. Would like to take this opportunity to thank all the jury and the team of STC for giving me a chance to present my topic, Performance Predictive Analytics using AI and Machine Learning. My name is Sudarshan Sridhara, and I work for Capgemini, currently at Atlanta Greater Region, working for a telecom giant. Well, for me, the journey did start during my AI certification a year and a half ago, which made me get into this realm deep. The inspiration was from the course on how Turing machines in 1950s were instructed to do certain jobs. With my love to mathematics and programming, applied this into reality to make machine learning possible in the cognitive world. Applying algorithms with proper analytical data to get to reality is what we would be discussing in today's presentation. As there are no tools close to this reality in the performance world, this topic makes it unique. Analytics has been one of the key outlooks in IT organization over the last few years. Most of the innovations and tools have evolved in descriptive analytics space, with only few dwelling in prescriptive and predictive analytics. From the industry trends, predictive analytics would take the center stage in the coming years, given the stress on automation and AI application usage. The shortest way to get this and achieve is by employing all powerful machine learning into predictive analytics and harnessing the decision skills required for artificial intelligence. Predictive analytics is used to make prediction using historical data. It uses various techniques like machine learning and statistical modeling to analyze the existing data, determine the patterns, and make predictions about future data. Machine learning algorithms can be classified into regression, classification, clustering, and dimension reduction with a density estimation. The next slide would talk about how the unstructured data flows as structured data to an algorithm and get applied into machine learning. The below diagram depicts how the sources of raw data, or what we call as unstructured data, like the response times from different tools, load runner, JMeter, or any other commercial tools, the throughput, hits per second, the server utilization, the configurations from all the servers, may it be the middleware, the GC patterns, the connection pool settings, the web services, all these raw data are fed into what is called as loaders. There are multiple statistical learning methods and also the classifiers applied on all these data, and the proper mind format data becomes structured, and then it moves on to the machine learning algorithms. So basically, the more we train the algorithms, better is the accuracy that we get. Okay, now we learned about how the data classification happens, but the basic question for us is how do we apply this in the performance engineering world, which would be covered in the next slide. All right, we have seen an application grow over a lifetime with its user base growing higher and higher. Will my SLAs remain the same? Or what component would be needed as a trigger point for my infrastructure scaling? I did a change to an application. How would it impact my load volumes? What would be my response time? Is my performance test required for an application at all? Predictive analytics can solve this scientifically and determine the need and amount of test required for a particular application, thus by reducing cost. So most of our applications in today's world have moved to the cloud, and a proper capacity planning with linear scaling is important as it saves cost. Honestly, at our telecom chain, we have applied these algorithms using R to find the perfect server size at all layers, from cloud to Apigee, middleware, which is TIBCO, databases, and Kubernetes. So why is this so important? Is because it saves cost, as it would predict how much CPU with RAM it's needed. So the permutation is apt for this program, and we would be discussing how did we do this in the next slide. All right, so let's imagine this as a pipeline, right? So we get all the raw data from, might it be a Slack bot, Splunk, App Dynamics, New Relic. We get a lot of data from, LoadRunner, JMeter, and also the developer data from the GitLab. And all these will have a classification done on the data collection, and it moves to the data preparation factory, and a proper mining would happen like we discussed before. And once this is done, there is a proper evaluation of the data, turning it into the base value for the prediction algorithm. So like I said, we used a lot of our algorithms basically on the linear regression, SVM, k-means, KNN, and the gradient boosting algorithm. This is the key part which played a proper role in our prediction, which made this very accurate. Honestly, when we started this idea a year and a half ago, it was just around 62% proper. But the accuracy came in really well when we did apply this gradient boosting algorithm, because it's a combination and gets you the best of the best. So once the data flows in here, the complete data compilation happens with proper supervised learning, and also a reinforcement learning algorithm which is applied. And once this is done, a decision making and movement would happen, and there would be a proper trend of all the response times with a prediction based model would be given. And also it will also show you what would be the CPU memory, the arc spaces, what would be the redis cache that would be needed, and all those permutations and combinations would be applied and then showed on the screen. So basically, if I tweak my CPU and RAM, how much would be an impact on the response times is what this whole program would show. And also it will show what's the error threshold, and also predict how much passed and failed would impact my server utilization, right? So all these smart AI based analytics is being given. So you get a prescriptive analytics with a predictive analytics with a 98.84 accuracy driven approach. So this was not easy, honestly. When we started this program, as I told you, we were bare minimum. We put in a lot of effort and then made sure that the algorithm sits in properly and get the best of it. So um, imagine this, right? So when we are doing a proper run, right? So we do in our telecom chain a lot of runs on production. There is a lot of data pre activities and the post activities that we do. To lessen this, what we did was we applied the same exactive predictive analytics and made sure that we were able to cut short few of the runs, because the prediction was flawless and accurate. um, we can do just the gets, we cannot do the post, because it will apply and then have intricacies on downstream system, or it might imply on customer data and so on and so forth. So just to be sure that how accurate this was, we applied it for 1 quarter and we got a proper accurate results. And the release that happened recently for the iPhone and also our Black Friday, it worked flawlessly and it showed us the proper results. So we were very confident that yes, this would apply. And then we said, okay, great, the all the algorithms gave us proper data, and we were able to prove that yeah, this actually works. So most of the industry is looking at the descriptive analytics, right, on the performance realm, and we have tools which gives us percentile calculation. I can get response time for 90th percentile, 85 percentile, 99 percentile, and so on and so forth, right? And we get all the hardware metrics and the trend analytics with the results comparison. This is the bare minimum that any of the tool is able to give us. But we went a step ahead with the predictive analytics by making a decision that is a test required based on the machine learning algorithm or not. So all the data that we are getting, we are able to show a recommendation for what would be the 3x's, or if we get a 500 error, where should we look at and what layer we should look at. There is a linear extrapolation of the maximum user load and the response times, and prediction based on the time since the last run is also shown on the screen. There is a rapid analysis based on the SLA adherence from the previous past runs, and diagnostic pattern for all the transaction response time is also shown on the screen. So these considerations make this solution unique and say that okay, we are able to achieve few good things in performance realm. Like I said, I would like to show the different stages that we followed. So the stage one was the root was seeded for the framework design, and there was an approval given a year and a half ago, and we started coding with R. Like I said before, we were just at 60% with the capacity predictions and also the sizing evaluation. Um, we applied a lot of coding and lot of tuning on the algorithms that we have done. There was a lot of capacity planning, transaction network captures that were done on real time and were applied on most of our algorithms that we implied to the real world. The lean on the stage four, we wanted to make sure that the predictions are accurate. So what we did, we just took the baseline of 1x and saw that there were few runs which were made on 3x and 5x and 10x. Does it actually give us a proper sizing evaluation? And for our surprise, it did give us. And all the sizing evaluation and parameters that we played on the network and also the hardware routers with the realistic data, it was able to give us a proper KPI based model. And also it was able to show us a lot of business flows with the transaction mapping and saying that okay, this might be your root cause for your problem, which was really surprising for us that we did train, we did make sure the algorithms were up to the mark, and we were able to achieve a lot in the linear scaling. So basically we were able to size the evaluation based on CPU, memory, and database. There was a lot of estimation models that we could derive of the data, and we were there on stage 4 with 98 accuracy. There are a bunch of tools in AI ranging from TensorFlow to Cafe to Swift AI platforms. This is unique implementation as we have focused on performance capacity planning and linear scaling. If you see the depiction here on the diagram, we see that the response time prediction for the next run with hardware and network parameters with realistic data given, because there are probes already fetching and feeding all the realistic data on our platform. So the second diagram, you see there is a prediction which shows on the SLA of the application if it's breached or not. It gives a variety of possibilities and deep dive on which component is actually giving this problem is also reality in this solution that we have developed. There is a there was an interesting question during our prelims that the jury asked by one of the teams, saying that can it be applied on new application? Absolutely, why not? If the configurations and the proper capacity probes are applied to the baseline data, it starts learning, and the actual behavior would predict the response times, hits, throughput, CPU, utilizations of the memory, and also it would recommend the proper GC algorithms that you want, and it also gives us the best configurations that is needed for the programs. as we are a telecom giant, right, we had a lot of billing systems that generates and stores on our FTP servers. So using this predictive model built into machine learning, it forecasts out where that model is expected to grow. Basically, on the FTP servers, when we applied, when the disk was, running low or the IO had a problem, it identified the anomaly in the real time and was able to report to us. So when we did this prediction multiple times, right, or during multiple intervals, we were able to control our FTP servers and also auto scale it both horizontally and vertically, which makes it very intuitive and also very unique. All right, I would just like to, step back and then show you how the AI metrics are shown on the dashboard. So with the various permutations and the combinations of the predictive models applied on the data with its accuracy percentage is shown on the screen. For the response times, we saw that the decision tree, linear regression, and logistic regression gave us the perfect results. This is just an example. Like these, the code which we have implemented has multiple parameters like server capacity, CPU, and memory, like I told you before, and what it can hold. We have an implementation of code which is around 2 lakh lines with 786 permutations and combinations of the algorithms that it applies and shows which model is the best on the screen. So this would decide and say that what can be applied and what cannot be applied, which makes it very unique. So let me conclude this topic. Basically, from our implementation of machine learning and performance analytics, we could already see the kind of impact and benefits that it could be realized in performance test and engineering world. When we started this out, there was a disbelief on the practicality of such machine learning and AI into the performance realm. But the results were really promising enough to venture into more into ever evolving artificial intelligence, where one day there would be, it would auto heal all the systems, and then based on the contingency, it would actually help us solve a lot of problems. That being said, let me take a few questions here. All right. The question was, the solution is applicable only for the telecom domain. How would the solution extend for others? So let me answer this. So practicality of application would be similar across domains, and this solution, what we have developed, could be extended to others with minimalistic efforts. Let me take another question. How often did you use this solution and what's the cost saving? So basically, like I showed you before, we use it daily in our production scaling system and also for our capacity planning for the disk IO and so on and so forth. The basic need was for optimizing the costs at AWS, and on date we have saved around 100K dollars across, and it's still evolving. We are just making sure that we implement it more and better, and more optimizations are coming in the near future. This is daily running on the production, and it's live monitoring across, and we have reaped the benefits, not only for FTP servers and also the disks, and we have optimized a few middleware servers on the TIPCO, and there were too many optimizations that we did on the Apogee layer too. So net, yeah, this is working, and I'm sure that it would reap a lot of benefits to the customers across. Thank you all for giving this opportunity, and stay blessed.